Welcome to Creative World. In this video, we will solve Learning Assessment 2.3. Read the scenario. Learning Assessment Example 2.3. Determine the peak output voltage for the rectifiers in given below figure. If the peak input in part A is 3 volt and peak input in part B is 50 volt. There are two half-wave rectifier circuits inside this figure. In figure A, the peak input voltage is 3 volt, while in figure B, the peak input voltage is 50 volt. And we have to find peak output voltage across these resistive elements in both circuits. We will start from figure A. Inside this figure a general purpose diode 1N4001 is utilized to rectify AC signal of 3 volt peak. This is a silicon diode. Forward voltage drop across this diode will be 0.7 volt. So the peak output voltage across 1 kilo ohm resistance will be calculated using this equation. V peak output is equal to V peak input minus diode voltage. In this case, the diode voltage is 0.7. So V peak output voltage will be 2.3 volt. 3 volt minus 0.7 volt. That will result 2.3 volt. And because it is a half wave rectifier, so the output waveform of this rectifier will be pulsating DC, having the maximum value of voltage 2.3 volt. Move towards part B. Inside this rectifier circuit, the peak input voltage is 50 volt and diode number is 1N4003. This is also a silicon diode, so voltage across this diode will be 0.7 volt, which is also known as forward drop voltage across diode. So peak output voltage across 1 kilo ohm resistance will be calculated using this equation. V peak input minus diode forward voltage. In this case, peak input voltage is 50 volt and diode forward voltage is 0.7 volt. So output peak voltage will be 49.3 volt. And again, this is half wave rectifier, so its output voltage will be pulsating DC, having the maximum value of 49.3 volt. So this was Learning Assessment Example 2.2. Thank you. See you again in next video.